Good morning. I am Shalysingla from JPC Cooney Majra. Today my topic is conservation of mechanical energy for freely falling bodies and transformation of energy. To start with the topic, first of all, I will define the principle of conservation of energy. According to this law, the energy can neither be created and nor be destroyed but it can be converted from one form to another. The examples of conservation of energy are: first is the when a moving bullet hits a target, it possesses kinetic energy. A moving bullet possesses kinetic energy. When it hits a target, its kinetic energy is converted into heat, sound and light energy. This is the first example of conservation of energy. Second is when a car hits a ball, the kinetic energy gets changed into heat, light and sound energy. This is the second example of conservation of energy. The third example is when a stone of mass m is dropped from a height h, its potential energy, which is mgh, changes into kinetic energy. So these are the three examples of conservation of energy. Now I will discuss in detail what is the mechanical energy. Energy have different forms. One of such form is called mechanical energy. This is further of two types. of mechanical energy. The first form of mechanical energy is the kinetic energy. Now every moving body has kinetic energy. So this is defined as the energy possessed by a body by virtue of its motion is called kinetic energy. The examples of kinetic energy are: number 1, a moving car, cycle, or any vehicle. Any moving vehicle possesses kinetic energy. The second example is a moving ball. The third example is water. Moving in a river or stream. This is the third example. Fourth example of kinetic energy is blowing wind. Fifth example is a moving bullet. Moving bullet also possesses kinetic energy. So these are the examples of kinetic energy. Now we will find the expression for kinetic energy. We know that if we have a body of mass m and it is moving with a velocity v, then the kinetic energy of that body is equal to half m into v square. We will derive this expression. Let we have given a mass m which is initially at rest. U is its initial velocity and it is equal to 0. So its kinetic energy at this point is also 0. Now we apply a constant force F on it. By this force the body moves to this point from point A to point B. Here its velocity is v and its kinetic energy is half of mv square. From A to B the distance covered by the body is s and acceleration is a. Now the constant force F acting on a body is equal to m into a, mass into acceleration. From equations of motion, v square minus u square is equal to 2as. V is the final velocity, u is initial velocity, a is acceleration and s is the distance. Now u is 0, So putting the value of u as 0, we have v square is equal to 2a into s. Now work done by force F. When we apply a force F on the body moves to distance s. So the work done by this force will be equal to kinetic energy of body. This work done will be stored as kinetic energy in the body. The work done is equal to F into S, force into displacement, and the kinetic energy is equal to half m into v square. Now putting the value of v square from this equation, 1 into 2, we have half m into 2a s. 2 and 2 are cancelled, so the work done is m into a into s. Now the value of acceleration a from this equation is a into s is equal to m into half v square. So we get half m into v square. So from this equation we see that this work done by force F has been stored as kinetic energy of the body. So we get this expression, kinetic energy is equal to half m into v square. Now second form of energy is the mechanical energy, is potential energy. The definition of potential energy is the energy possessed by a body by virtue of its shape, position, or configuration. Is called potential energy. The examples of potential energy are: number 1, water stored at a height h in dam. In case of dams, the water is stored at a certain height h, so there is a potential energy. Second example is a stone raised to certain height. Anything which is taken away from the ground level possesses potential energy. Third is a stretched rubber band or a stretched bow also possesses potential energy by virtue of its configuration. Fourth example is a wound up spring of a watch. So these are the certain for few examples of the potential energy. Now we'll find the expression of potential energy. Now let us take an example. Suppose a body of mass m is lying on earth. The potential energy at this point will be 0 because the height is 0. Now it is taken to a height h, and we have to find the potential energy at this point. This point is A and this point is B, and we apply a force F for moving the body from point A to B. Now the expression for force acting on this body will be equal to m into g, where m is the mass and g is acceleration due to gravity. If we take anything away from the earth, we have done work against the gravity. So the acceleration will be equal to g, and it will be equal to 9.8 meter per second square for the case of earth. So this is a force. Secondly, the distance moved by this force is h. S is equal to h, because the body has moved from A to B with a height of h. Now the work done by the force F is equal to W. This work done will be equal to F into S, force into displacement. The value of force is m into g, whereas the value of S is equal to h. So this is equal to mg into h. So this work done has been stored in the form of potential energy. So this is the formula of the potential energy for a moving body from point A to B. So this formula we have to remember. Now the next is conservation of mechanical energy for freely falling body. We know in this case the mechanical energy is of two types: potential energy and kinetic energy. So in this case we will find that total value of potential energy and kinetic energy or total mechanical energy remains constant for the case of freely falling bodies. Let us take an example. This is the ground level where h is 0, and this is height h. This point is taken as C. This is point A, and in between we take a point B. Let us take a body whose mass is m. Suppose this body is dropped from this point A, then we will see the different types of energies. Now let us start from point A. At point A, firstly we will find the kinetic energy at point A. At this point, initial velocity is 0, because when we drop a body, we don't give any energy to it, so u is 0. So in this case, the kinetic energy will be also 0, half m into v square. This will be equal to half m into 0 square. So kinetic energy is 0. Now we will find the value of potential energy at point A. The potential energy is equal to m into g into height. Now the height from the ground level to the point A is h. So the formula for potential energy is m into g into h. Now total energy is equal to kinetic energy plus potential energy. The value of kinetic energy is 0 and potential energy is mgh. So total energy is equal to mgh. This is the equation number 1. This is total energy at point A. Let us draw the diagram. These are 3 points A, B and C. This height is h, u is 0. From A to B, the height is x, and from B to C, this is h minus x. Now we will find the total energy at point B. At point B, the kinetic energy is half m Vb square, where Vb is the velocity at point B, and at point C this velocity becomes Vc. Now we will find the value of Vb from equation of motion. V square minus u square is equal to 2as. This is the equation of motion. In this case, V is our Vb, u is 0, is equal to 2. Acceleration is g, and s is the distance covered, which is x. So we get Vb square is equal to 2gx. The kinetic energy is half m into 2gx. This is equal to m into g into x. This is the kinetic energy. Now we will find the potential energy. Potential energy is equal to m into g into the height of this body of mass m from the ground level. The height is h minus x. So this is the potential energy. Total energy is mgx plus mgh minus x, this will be equal to mgh. So total energy again comes out to be equal to mgh. This is the second equation. Now in the third step we will find the kinetic energy, total energy at the point C. We will find the total energy at point C. At point C, kinetic energy is equal to half m Vc square. At this point C, the velocity is Vc, so kinetic energy is half m into Vc square. Now we will find the value of Vc from the equation of motion. The equation of motion is V square minus U square is equal to 2a into s. Putting the values, V is equal to Vc square minus U is 0 at point A. This is equal to 2 into A is equal to G and S is equal to H. So Vc square is equal to 2gh. Kinetic energy is equal to half m into 2gh. This comes out to be equal to mgh. Now potential energy at point C is equal to m into g into height. The height at this point is equal to 0. So the potential energy is 0. Now total energy at C is equal to mgh, kinetic energy plus potential energy is 0. So this is equal to m into g into h. So this is the third equation. So we will find that at these 3 points the total energy is always equal to m into g into h. So we can conclude from 1, 2 and 3, we conclude that the sum of kinetic energy and potential energy at different points of motion for a freely falling body remains always constant. So this is the conservation of mechanical energy for freely falling body. If we draw a graph between energy and height h, let us firstly draw a graph between potential energy and height h. This will become like this. Here h is equal to 0 as we increase the height, the energy, which is potential energy, goes on